Hey guys, this is Andrew Dail, and in this video we're going to be talking about the milling vise. Now, if you want to make somebody really angry at work, mess up the mill vise. And I tell you that because 90% of the jobs that you do on the vertical mill involve this vise. When I say mess it up, if you take and loosen up the bolts on either side of the vise and it's not what we call dialed in, that's going to aggravate some people because this vise is set up for most of the work. We know that it's square to everything, and if that vise is out of square, then the result is that the job you're trying to do is out of square. So don't mess up somebody's vise, and if you do have to take it off for some reason, make sure when you put it back that it is dialed back in, and that's what we're going to talk about here today. So let's take a closer look at the milling vise. Now, a couple things I want to point out. It has this little stop over here, and it's this little piece here is useful so that you can get a repeatable stop. You can install something in here, lock it down, and then that becomes a 0 point for setting up all of your work. All right, so let's pretend that we're going to do some milling on this block of steel. Okay, now when we open up the jaws of the vise, all right, we can slide this in, and you'll see that it slides all the way to the bottom. Okay, now to help that, we have these things that are called parallels. And here's a little case. I've got the parallel set over here, and these parallels, their job is to hold the work parallel to the vise. Okay, so a couple of things here. You'll want to make sure that you've cleaned off any chips that might be sitting inside the vise. Throw the parallels in. All right. And that's going to lift your work up so that we can then clamp it into position. So that little stop that I was talking about there, that we loosened up and moved around, that can, if you're doing repetitive work, you can slide the work against the parallels, then push it up against that stop, and you know that it's zeroed in, so if you're making many parts the same, you don't have to find the parts all over again. So to lock the work inside of the vise, you're going to want to make sure that it's resting flat up against those parallels. So we're going to put the work in and then kind of get it about where it should be. And then you want to tap it down kind of while you're tightening on the vise. And that's going to help make sure that this block is down against the parallels. And actually, if done well, you can't slide the parallels out. I'm trying to move them out. You can tell that there's a little bit of tension that's put on those parallels. Okay, so we've locked something in, and we know that it's square, it's ready to go. So typically, after we've got the work clamped up in the vise, we're going to want to remove the vise handle, set that on the cart off to the side here so it's not in the way of the machining. Again, all the extra tooling and stuff, we can slide that out of the way. Okay, so that's an example of getting our work clamped up on the vise. It's not going anywhere. We can do what we need to do. But how do we know if this is square and ready to go? So with that, we're going to use our friend, the dial indicator. That's going to let us know if our vise is square relative to the x-axis or y-axis on the bed of the lathe, or bed of the mill. So let's demonstrate how we're going to do that. I'm going to pause for a second while I get the dial indicator chucked up to show this. You're good? Nice. Beautiful. I like that. So that's where you're going to connect your power?
Yeah.
Perfect.
You got to connect the red one now.
Yep. And then they go all the way through. And that's where the negative. Yeah.
Right.
I like it.
Okay. Bam. Well, I took a little lesson from the other one.
Yeah.
Yeah.
Yeah. The highlighting thing, it does help, I think.
Yeah, it does.
You're like, oh, I know what I did.
I know for sure now that I started out with the 0.
Yep.
And I got the power, So if I wanted a fuse now, it would just be another extension from here to the fuse.
Yeah,
to
we
the
could
top.
interrupt this, put a fuse in line with it.
And that would regulate how much
Uh,
power go through.
It doesn't regulate.
Doesn't regulate it. What does it do?
It
Current.
it's the amount of current it will let go through without blowing the fuse.
Without blowing the fuse. There we go.
Yep. So in that case, if it's a 1 amp fuse,
Mm-hmm.
if you had like 1.25 amps
Yeah.
try to go through, then it would trip. And it's not going to trip exactly at 1,
Right.
right? It's got to be above it by a rough mount.
So when these come on,
Oh, what do we have going on with this anyway? I had that hooked
Oh,
up for something
this-
else.
I think this is it was just there. So it would be okay.
There we
I'm
go.
getting my power from this guy.
Yep.
Okay.
Yep, and that should be at 24 volts.
24 volts.
Yep. Okay.
Okay. They're all lit, but this one's got more light than the other ones.
Yeah. Yeah, and so I did this circuit because it gets us thinking forward about series and parallel circuits. Okay. The one that's basically positive to negative is
Yeah.
the brightest. This is the brightest.
That
'Kay.
single one.
Yep. And when it goes through 2, these guys, they're the second brightest. And when it has to go through 3, they're the dimmest. And you can actually, if they are on.
They are on, yeah. I could see that this is the brightest. These go next, and this is a series.
So yeah, when they're all in a row like that, that's called series. And we usually don't wire things up in series too much. But what's interesting about this
Yeah.
is that when we measure the voltage across the brightest bulb,
Mm-hmm.
well, if you think about where this is connected, it should be 24 volts,
Right.
right? So that's this guy. One end is connected to 0, one's connected to 24. Not a surprise that that's at 24. Okay? Now check this out.
Don't tell me that one's gonna be lower. Oh,
12.
wait a minute. They split up.
It splits the
24.
yeah, because this has got 2 of them in a row. It's splitting the voltage, so each is about 12. 12.
You still have the 24, but you sharing
Yeah, if we go
two lines.
across here, I got the full 24, but it's got to go across 2 bulbs. That's where you're getting 12 and 12.
So let me guess now. It's gonna be 24 division to 3.
Uh-huh.
Give me 9 at each.
8.
Or 8 at each.
Yeah,
8 at each. Okay.
yeah. So you go across here, that's about 8 volts. And that's why they're the dimmest.
Okay. So when you're doing parallel, you don't want that. It's a different way.
Yeah, if we have everything hooked up in parallel, every single bulb would be at 24 volts.
And then the schematics won't look like this either.
Correct. If we had 6 light bulbs in parallel, the schematic, do you have a pen over here? All right. So if we had 6 bulbs all in parallel, then they'd all be at 24 and they'd all be bright.
Wait a minute. It's gonna be. What's going on, but. Oh, we changed there. Would all these be connected then?
Mm-hmm.
Is that what it is?
Mm-hmm.
Ah.
Yep.
So I'm gonna have all 6 negative,
Yep.
neutral, all 6 positive.
Yep.
I see.
Yep, yep.
Okay, and then I'm gonna get all the same.
You got it, man.
Okay.
I don't know if I have any of that stuff in here. No.
I think I'm gonna do that tomorrow.
Yeah?
I wanna try it tomorrow.
It's time.
Oh, it's only 7:15.
Yeah.
Oh yeah.
If you wanted to do that, I mean, you're welcome to.
Yeah. I want to see how that comes out.
And what I would recommend that you do, you could leave this one connected and grab all new bulbs that are green or something.
Oh, okay, I see.
And
try it out that way.
What I'd recommend is that these wire terminals are designed so that you can get 2 wires in there, one on either side of the screw. So, you know, you can install a wire here,
Okay.
and you can install a second wire over
right
here.
between the screw. Okay.
Yeah, so one on either side of the screw. So you could create that network of just going one to the next and the next and the next.
I see. I see. Okay, let me try that.
Yeah, and there's more wire. Feel free. I don't care if we burn up the wire. That's what it's there for. I'm paused. Get them all wired up.
We got some wire. Getting them a little bit. Nothing to see, nothing.
If you're having a hard time stripping, move to the next larger gauge.